So variation notes. So this is Tuesday, April 1st. It's really only two topics today. One is direct variation, and if you turn your paper over a little bit, you see inverse variation. So those are the two things that we'll talk about today. In fact, you can kind of see their difference in the equations right there. Direct is k times x, inverse is k over x. There's the lesson in one sentence. Back up a little bit. Direct variation means as x gets bigger, y gets bigger. As x gets bigger, y gets bigger. That's an easy to come up with an example of. Like if you have a job, the more hours you work, the bigger your paycheck gets, the more money you make. It's direct variation. If you work twice as long, you get twice as much money. I guess that breaks down eventually because you get overtime, but up to 40 hours, you work twice as much, you get twice as much money. That's direct variation. The in thing, only use a power if it's mentioned in the problem. It usually isn't. At least in Algebra 2 it's not. A little later we use it more often. But it'll be clear if it does. It'll say something like varies directly with the square of x. So if you're supposed to square x, it'll be clear that you're supposed to square x. So I wouldn't worry about that. It also is not going to happen for us. But later on, it'll still be the k situation, but square of x would mean x squared. Constant of variation, also known as the constant of proportionality. K is a, don't overthink this, constant. And if a constant, it does not change. I had to look up those blanks because I was like, is it really that simple? Like, yeah, that's it. K is a constant. It doesn't change. So once you start a problem, once you figure out what K is, you keep K for the rest of the problem. Now, in the next problem, K might be something different, but within one problem, K is not changing. Y equals Kx. That's the direct variation equation. That's kind of all you need to know for today. Direct variation means y equals Kx. Everything else kind of falls out of that. So what's the ratio of y over x equal to? K. You divide both sides by x, you get K. But you don't need to memorize that. Like you look at, as long as you know that y equals Kx, you can figure out what K is. The rest of this stuff is more confusing than helpful, so mark that out. Direct variation, y equals Kx, as opposed to inverse variation, which means as x gets bigger, y gets smaller. As x gets bigger, y gets smaller. Again, with the n in the bottom, you're not really going to have to worry about that. It'll be clear if you do. There's the formula for inverse variation. There's a couple ways it could phrase this. The most direct way would be y varies inversely with x. Y varies inversely with x. So that's when you know it's inverse variation, so it's y equals k over x. They can phrase that a little bit differently and say y is inversely proportional to x. Those mean the same thing. The key word is obviously inversely. That's what triggers inverse variation. The product xy, well, if you multiply by x, xy is k. The rest of that worksheet is garbage. So all you need to know is direct variation. Get them both on the same page here. Y equals kx. Inverse variation, y equals k over x. All right, the assignment are these silly math worksheets, usually given to middle schoolers and elementary schoolers. Have y'all seen these before? You work some problems and the answer is a terrible pun of some sort. So let's look at this first one. Why did the painter go on a safari? Cross out the letters above each correct answer. When you finish, the remaining letters will spell out the answer to the question. So be careful here. We don't want to circle the answers. We actually want to cross them out. Let's try 1 and 10. So number 1, y varies inversely. By the way, this entire worksheet is inverse. So you might want to put at the top y equals k over x because they're all inverse problems. No, there's not a lot of room to work, but there's not a lot of work to do. Y varies inversely with x, so y equals k over x. And y equals 16 when x equals 3. So 16 goes in for y, 3 goes in for x. So what's k equal to? 48. So y equals 48 over x. And then we look for that equation. Y equals 48 over x, which is this AT equation. I'm going to label it 1. You don't have to, but this would be a place where if you mess up and your answer doesn't make sense, so you know you made a mistake somewhere, it'll be easier to find if you label them as you go. So that was question 1. We marked that one out. What's that?
Why is it over x?
Oh, it should be over x.
Then why is it over x?
Because all the way back, they're all going to be y equals k over x.
Oh,
Because they're all inverse. I mean, they're not all over x because sometimes they use different variables like L. And then on the bottom, you see more variables R and W and L. But the setup is always y equals k over x. Let's jump ahead to number 10. The directions change on us. In exercises 10 through 13, write an equation expressing inverse variation, then solve the problem. Cross out both the equation and the solution. A few people raced ahead and couldn't make sense of their answer, and it's because they didn't follow the directions. Okay, so number 10. For rectangles with the same area, the length varies inversely with the width. So this time, instead of x and y, we'll have to use L and W. L varies inversely with the width. Suppose a rectangle has length 105 and a width of 60. So k is 60 times 105. Which is 6,300. So my equation is L equals 6,300 over W. I'm going to go ahead and look for that right now. If I don't find it, that means I did something wrong. Where'd it go? There it is. 6,300 over W is IT. I'm going to mark that out. Label it question 10. But I'm not done. Find the length of another rectangle with the same area whose width is 75. So L equals 6,300 over 75. You got a calculator, so 6,300 divided by 75. L equals 84 feet. all the way there at the end. So 10, 11, 12, 13, make sure you find sort of both answers, the equation and the answer, then mark them out. Your answer will be a very bad pun. All right, the next worksheet is, I feel like we're out of order because the next worksheet is all direct variation. I'd like to pat myself on the back. I figured out the answer to this one before I worked it, or at least I was close. What does Alabama have that most students would like to have? Well, work the problem and get the dumb answer. Let's do number 5 together. Make sure we're on the right track. Oh, read the directions, of course. Write an equation expressing direct variation. Find your equation in the answer column. Then use the equation to solve the problem, and write the letter of the equation in the box above your solution. So this one's rigged up a different way here. Number 5. The amount of money earned on a job is directly proportional to the number of hours worked. The number of hours, if 76 is earned for 8 hours, and 76 divided by 8 is 9.5. $9.5 per hour. So the equation is y equals 9.5x. So now I look for that equation. It's down toward the bottom. Again, I'm going to label it number 5 just in case I need to go back and check something. But I'm not done with this problem. How much is earned for 34 hours of work? So 34 goes in for x. And that's $323. So that's the ultimate answer I'm looking for. It's already filled in. $323 is where the A goes. So, pretty simple couple of worksheets. Just a lot of practice on direct variation and inverse variation. And then you get 2 terrible jokes as answers. Worse than dad jokes, both of them.